Welcome back, chemistry fans. Today we are going to tackle Unit 8, Topics 3 and 4. This is the second half of our acids unit, so let's jump right into the homework and see how it is going. Let me share my screen with you. And then we'll get to the program. Here we are. Okay, so you're going to need a calculator, scientific calculator, to solve this one. It's virtually impossible for you to do this without. It's asking for the pH if you are given the concentration. Well, what you're going to have to know about pH is the formula. Negative log of the hydrogen ion concentration will be equal to the pH. So all we're going to do is we're going to plug that value into the equation right there. So we will do, on the calculator, negative log of 2.9 to the exponent of negative 9. And so if you are looking at my screen, oh my goodness, it's so dark. I'm not sure you're going to be able to see that. Maybe. There we go. Now you can. Put that in, and you will see what your pH is. Your pH is 8.5. Very, very simple task if you have the formula to do that with. Now, number 2, it's the exact same formula, except, well, how would we reverse it? So what you're going to have to do is figure out that, first off, pH plus POH equals 14. So what we're going to do is we're going to take this POH and turn it into respective base kind of perspective. So we're going to take the 3.4 plus what will be the POH and make that equal to 14. So that's 14 minus 3.4, and it gives you 10.6. That is your POH. Okay, now what we've got to do is we got to invert this. So what you do is you inverse the logarithm. And so we're going to have a 1 times 10 to the power of negative POH. So what does that mean? Well, you're just putting this into your calculator with a weird decimal as the exponent. So it'll be 1 times 10 to the negative 10.6. You're like, that doesn't make, and I get that, but the calculator will make sense of it. It will turn it into a decimal for you, or it will turn it into, yeah, it's going to turn it into a decimal because it was a POH value. So we'll do 1 times 10 to the negative 10.6. So what I did there, again, is I plugged it into my calculator. Another way of doing that is to say times 10 caret 10.6. All right, hold on. Let me do that again. There it goes. Okay, so now I've got it in the correct format. 1 times 10. Oh my gosh, it won't, the reflection will not pick it up. There it is. Well, it's so close. And so what you end up with, 1 times 10 to the negative 10.6, and you get the hydroxide ion concentration of 2.5 times 10 to the negative 11th. Okay, last question is dealing with the Ka value. So this is a multi-step problem that we're going to have to deal with. So in this formula, what we have to understand, this is a weak acid, so you can't use the pH formula directly. So what we first have to do is understand the Ka is the acid dissociation, and that's products over reactants. So in this dissociation, we have H3PO4. It is going to dissociate into 3 H's and 1 of the PO4s. So that is going to be my products that it makes. What it started with as a reactant is 6.2 molarity. So now my Ka value is given to me as a 3.9 times 10 to the negative 6. What we don't know up here is the acid concentration. That's what we're looking for so that we can plug it in and solve for a pH value. So what we have to do is understand how many parts did it break apart into? Well, it broke apart into 4 of these X's. So it would be hydrogen times hydrogen times hydrogen times the PO4. So it has 4 of these pieces that it's breaking apart into. But we're only going to be concerned with the hydrogens. Okay, so how we should think about this. I have 3 of these hydrogens. So each one of those hydrogens, they're going to be in equal amounts because they're each breaking apart into the exact same amount. You can't have a higher number of the first hydrogen than the second hydrogen because if you break apart into 3 equal hydrogens, each one will have the same exact concentration. For every 3 hydrogens, there's going to be 1 phosphate. So they're all going to have the exact same concentration. So what we are able to do here is combine those into an x to the 4th. All right, so here's what our final equation is going to look like. Well, our next to last. 3.9 times 10 to the negative 6 is x to the 4th over 6.2. So algebra, we're going to combine these 2 pieces together. So 6.2 times 3.9 exponent to the negative 6. You plug that in, and you get x to the 4th is equal to 2.42 times 10 to the negative 5th. All right, but we need the concentration of one of those x's. So what we got to do is do the 4th root of both sides. Whoops, I don't know why it did that. 2.42 times 10 to the negative 5. Now, this is going to take a little bit more knowledge of your calculator. You're going to have to use the math screen. And then when you get to the math screen, there is an option for x square root. You're going to choose that. But before we do that, though, we need to put in a 4 in front so that it will look like this. So it's going to have an x to the 4th root or a 4th root button. If you know a different way to do it, you could always do a exponent to the 1/4 power. That would also get you there, but this is how I'm going to choose to do it. So I put in my 2.42 exponent to the negative 5, and we push our enter button. So this is what my work looked like as I was doing that. And what I end up with is my x value is equal to 0.0701. So this is my individual hydrogen ion concentration. Okay, to finish this off, we got to remember how many hydrogens did we have? If this is the concentration of one of them, we would need to multiply that by 3 for the total hydrogen ion concentration. So the total ion concentration for hydrogen is 0.21. Now we know our hydrogen ion concentration. The pH now is negative log of 0.21. And we get 0.67 as our pH. That's our final pH for this problem. So it's a long-winded problem, lots and lots of math. Hopefully you're following along. We'll practice it a little bit in class as well. Thank you very much for your time. Good luck. See you soon. Bye-bye.